Hello, welcome to Everyone Can Code. This is Development 101. If you've never programmed at all before, this video is for you. It's designed to give you the basic knowledge you'll need to get started with programming in Python, the programming language we're using for this event. Let's start with the absolute basics and look at the main parts of a computer. First, we have the Central Processing Unit, or CPU. It runs the instructions in your computer program. Next, we have Random Access Memory, or RAM. The RAM is responsible for storing the information that's in your program. It's very fast, but it can only work as long as your computer is turned on. Then finally, we have a disk drive. Disk drives can hold your programs, even when your computer is turned off, but compared to RAM, it's very slow. But what is a computer program? Well, a computer program is a list of instructions that's stored in memory, and if it's not in that fast memory, RAM, it needs to be loaded from the disk drive, even though that's very slow, in a language the CPU can understand that the CPU will execute in order. Now, when I'm not programming, I love to cook. And when I'm cooking, I need a recipe. So what is a recipe? Well, it's kind of like a program. Or rather, I guess a program is kind of like a recipe. A recipe is a list of instructions that's stored in your memory, in your brain. Now, if it's not in your brain, you need to load it from the recipe book before you can use it. It's in a language specific to cooking, using cooking terms like bake or broil or a cup or an ounce. And you need to do these instructions in order, just like a computer program. Now, computer programs wouldn't be very useful if they could only do one thing exactly the same way every time. That's why we have variables. So variables are bits of information in the computer's memory. Now, you can give them a name, and the name should describe what you want to store in them. So looking at these pictures, we can see a bunch of moving boxes, and on each box is written what's inside. So that's kind of like a variable, and just like a moving box, you can store anything you want in them. So in Python, if we wanted to create a little area in memory called my name, and we can store the value Jason in it. And we say my name equals Jason in Python. We can also relate this idea of variables to a recipe. So let's imagine we're making a pie recipe. Well, we'll preheat the oven to 375 degrees Fahrenheit, put the bottom crust in the pie dish, then we will add the pie filling of our choice. That pie filling of our choice, well, that's our variable. Add the pie filling of our choice, whichever one we want, to the pie dish. Put the top crust over the filling, crimp the edges, and place it in the oven for 40 minutes. So if we were writing this out in Python, it would look like this. Our pie filling is cherry. That variable, pie filling, contains the value cherry. And we can use the print command in Python to print things on the screen. In this case, print I love whichever pie filling, pie. So if we were using cherry pie filling, this would say I love cherry pie. Another important concept to understand when programming is the concept of functions. Functions are a list of instructions that are grouped together for convenience. Now, as programs get longer and more complex, they can be difficult to understand them or follow them and understand what they're doing. What functions allow us to do is just say, do all of these things without specifying each instruction again and again and again. Let's look at how this might happen. So in Python, let's imagine we wanted to say hello to a lot of people. We wanted to say, hello, Jason, hello, Maggie, hello, Umberto, hello, Alice. Well, we could type that out many times, or we could put it in a function. And by putting it in a function, we can just run the say hello to people function, which will follow all of these instructions again and again and again. Now we can also take those two concepts and put them together. We can insert variables into our functions to change the way our functions work. Variables that we add to functions in computer science lingo are called parameters. So let's say we wanted a function called say hello that will say hello to whatever name we give to the function. So we create a variable called my name, just like we did before, and then we pass that value as a parameter to the function. So now when we say hello, my name, and my name contains Jason, what's going to happen when we run say hello, it will say, hello, Jason, or whatever name we pass to it as a parameter. And again, this is just like making a recipe. Imagine we're having this conversation. Your boss comes up to you, the manager of the bakery says, bake me a pie, please. And you say, what kind? And he says, apple. All right? So what he's done is he passed you the pie name parameter, and you're going to fill that with apple. So we are going to preheat the oven to 375 degrees Fahrenheit. We're going to put our bottom crust of the pie dish. We are going to add the pie filling of our choice, the variable, which is apple, to the pie dish. We're going to put the top crust over the filling and crimp the edges and place in the oven for 40 minutes. And so we have run the make a pie function with the type of pie variable. Another important concept in programming is the idea of lists or collections. So if you look back at our function where we just printed the names of all the people, Jason, Maggie, Umberto, and Alice, it would be difficult to add new names or remove names from that function so we could say other people's names. We would have to recreate those print statements over and over again. Pretty much all programming languages have the idea of a list. And a list is essentially a list of variables where you can have more than one of them in a list. And then you can do things to every item in that list the same way. So here's how you do it in Python. Let's imagine we have this list called my list of names that has those familiar names, Jason, Maggie, Umberto, Alice. In Python, we can say, for name in my list of names, print hello name. And with this case, it would say, hello Jason, hello Maggie, hello Umberto, hello Alice, much in the very same way that our earlier function did, but in a much more flexible way. We can much more easily add names to the list or remove names from the list. Why, we can even get individual items from that list by their number order. So if we say print my list of names, and we include those square brackets and we say 1, it will say, hello, Maggie. Hello, Maggie? Wait, why doesn't it say hello, Jason? Well, the reason for that is because in Python and most other programming languages, we start counting at 0. So if we said my list of names 0, that would be Jason, and 1 is Maggie, 2 is Umberto, and 3 is Alice. That's a really big gotcha when it comes to programming, so be sure to look out for it. So one thing we frequently have to do in computer programming is sometimes we need to run some code, but other times we might need to run other kinds of code. For example, let's imagine a game where you flip a coin and it's heads you win, tails you lose. And if the coin has landed on heads, you need to say you won. And if the coin has landed on tails, you need to say you lose. So how do you do that in a computer program? Well, as you can imagine, we use the if statement. The if statement returns a Boolean value. That is to say, a value that can either be true or false. Now, if the statement evaluates to true, we run the code inside the block. So, for example, if coin is heads, we will say you win. Or we can execute other code if it's false by using the else statement. If the coin value is heads, print you win, else print you lose. And here's what that looks like in Python code. So we take one of those variables and we set its value to Jason, and we say, if my name is equal to Jason, print you are giving this presentation right now, because I am. Else, print you are not giving this presentation. Why? Because your name isn't Jason and you're not me. One thing to look out for: most programming languages, Python very much included, uses one equal sign to set a value to a variable. So we can see my name with one equal sign is Jason, and that means we are taking that value Jason and putting it inside of that variable, my name. But we use two equal signs to test for those true or false values. If my name equals Jason, another gotcha you really need to look out for when you're programming. Sometimes your program needs to do something over and over and over again. That's called looping. We've already seen something like this in an earlier slide. For example, when we were printing out that list of names, we said for name in my list of names. Well, that is going to do something for every single name in that list, my list of names. It's going to loop over all of those things over and over and over again. Now, we can also repeat things a certain number of times. For example, let's say we wanted to do something 5 times. We would say in Python, for x in range 5. That's actually a little unusual construct that's unique to Python, but since we're going to be doing this challenge in Python, it's something we definitely need to know. Or we can keep repeating as long as the condition is true. So we can say while my name is not equal to Jason. Oh, by the way, that exclamation point equals means not equal to, just like equals indicates is equal to. So while my name is not Jason, it's going to repeat forever and ever and ever until the value of my name is changed to Jason. Now again, let's bring it back to this analogy of making pies in a bakery. So let's imagine we have a list of names and we're going to write their names on the box. So what we're going to do is for name in my list of names, we're going to make a pie and we're going to write the name on that pie box. And we're going to pass the parameter to that function of the name. Let's say we just wanted to make 5 pies, 5 of the same kind of pie. We would say, for x in range 5, make pie. Now, let's say we really have a tough boss, and our boss wants to just keep making pie after pie after pie as long as the bakery is open. Well, while the current time is less than the bakery closing time, we're just going to keep making pies forever and ever and ever. Another important thing that we haven't mentioned yet about variables is that any variable you create in Python has a data type. The data type is the kind of data that you can store inside of that variable. So if you say word is equal to hello, then Python will create that variable called word, and it will use the data type str. That's short for string. A string is a string of individual characters like HELLO. The data type determines what kinds of operations you can do with your variable. So for example, let's say you had a variable called a that you set to the value hello, and b that you set to the value of world. And then you said print a divided by b. Well, that will result in a very obscure, difficult-looking error. It will say type error, unsupported operand types for str, for string, and string. Because, why? Well, it doesn't make sense to divide a word by another word. So we don't really need to say what data types things are when we create them. Python can figure it out by itself. Now, here's some important types that we've seen. We've seen str for a string of text. We've seen int, int, for an integer number. And we've seen list. A list can be a list of values. There's a couple important data types we have not yet seen. We haven't seen float. That's a floating point number, a number with a decimal point, for example, 6.5. And we haven't yet seen a dict, short for dictionary. A dictionary is a lookup table of key and value pairs. Here we have a cherry pie dictionary. And our first key is flavor, and its value is cherry. Our second key is crust, and its value is lattice. The key baking temp has a value of 375. Now you'll notice that 375 is not in quotation marks like cherry or lattice. Why? Because it is an integer, not a string like cherry and lattice are. And then our last key, ingredients, contains a list. So our ingredients are the list which contains the values cherries, flour, butter, sugar. So if we print out cherry pie and we say we want to see the crust of that pie, it will tell us that the value for that key is lattice. And if we want to look at that list of ingredients and see, as we say in computer science, the 0th ingredient, it will show us that that is cherries. And in this manner, we can build elaborate data structures because the value of any of these keys can be any data type. It can be strings, it can be integers, it can be lists, and it can be other dictionaries. So we can have one data structure called cherry pie and another called lemon meringue pie. And we can even have a list of all of these dictionaries. So all my pies contains the cherry pie and the lemon meringue pie. And we can say things like all my pies 0 crust will give us lattice because the cherry pie uses a lattice crust. And in this way, we can build very complex data structures to hold information in convenient ways. Now, I don't know about you, but my favorite code to use is somebody else's. Let some other person test and refine and debug this code. And when we use libraries, we get to use somebody else's well-tested, well-built code and use it for ourselves. You can also see them called modules, that's what Python calls them, or packages. And when we want to use them in Python, we're going to use the import keyword. So let's write some code to print today's date using Python's datetime library. So the first thing we need to do is load it into our code so we can use it. So we use the words import datetime. Then we can just print today's date. Print datetime.date.today. And that will output, well, on the day that I wrote this program, 2024-04-02. One of the reasons that Python is so popular in the programming world is because of the quality and the quantity of the libraries that are available for it. And again, kind of stretching our baking pies in a bakery analogy, it's much easier to use somebody else's pie than it is to bake ours from scratch. So we can just import that pie crust and use somebody else's, let them do the work. Now, all of the code you've run thus far has run on your computer. You wrote it, you built it, you just ran it. But what if you wanted to get information from the internet? Or if you wanted to send information to it? Well, services on the internet will publish their application programming interface, or API. And you can call those APIs over the internet to either send your information to a server or to get information from it. So once again, extending our analogy even further, let's imagine we call up the bakery and say, what kind of pies do you have? They give us a list of pies. We have called their API, and their API returned a list of pies. So there's a Star Wars API called swapi.dev. There's actually lots of different free, cool APIs for you to use in your program. Now, most of them are going to require an API key. That's a secret key that you must send with your request so people don't abuse it. But the Star Wars API actually does not need one. So the first thing we're going to do is import a library, in this case an HTTP client. That's for talking to web servers. And we're going to use that client to open a connection to the Star Wars API. And then we're going to tell it we want to get the planet. We want to get planet number 1. It's going to get a response from that server. And now we're going to print out that response by calling response.read, and it is going to give us the data. And the first planet in the Star Wars API, as you can imagine, the first planet we see, Tatooine. So now you know absolutely everything you need to know to program professionally, right? Well, of course not. This is meant to be a high-level introductory overview for getting to know basic concepts of programming in Python. Fortunately, all of you are going to break out into your teams, and every team is going to have a coach. And that coach is going to be very skilled in Python development and programming in general. So please lean on your coaches, ask them any questions that you might have, and they'll be happy to help. Thank you all so much for coming to the Everyone Can Code event. Happy programming, everyone.